thank you everybody for making it to the office, and hi to everyone on Zoom. Pleasure to be here. So my name is Julien. I'm the Chief Evangelist for Hugging Face. That's what the slide says. What I'm doing is traveling quite a bit, and meeting with customers, trying to explain to them that open source AI is actually the way to go about this AI business. And I'm also working with our partners. We have cloud partners, hardware partners, and that's a fair amount of my time as well. So in this presentation, which I'd love to keep as interactive as possible. So please jump in, ask questions, interrupt me. It's difficult for me to keep track of the questions on Zoom. So yeah, if you would kindly relay the questions of our friends. I don't want everybody to feel excluded from asking questions. But in the room, you have no excuse. Just wave at me or yell at me or throw things at me, okay? And let's have some fun and learn together. So what I'm gonna cover today is quick background on Hugging Face. We've been doing quite a few things lately. You may not be completely up to speed. And then chat about some of the latest trends that we see on LLMs. And so this is where I go super opinionated. And again, I'm trying to force you to react to some of that stuff to get the conversation going. So just have at it, okay? We're in Texas. We can, okay? Don't pull guns, okay? No guns, but all right. That's fine. I don't have mine, so it's not fair. And we'll do demos, okay? We'll do demos. I'll show you some of the cool things we've been building, and yeah, and again, answer questions as many as we can. Okay, so quick word on Hugging Face. So Hugging Face is the home of open source AI, right? In a few years, we've become the de facto place where the community comes to find models and data sets and also share them. Okay, who has shared the model on Hugging Face or uploaded the model on Hugging Face? Okay, all right. All of you need, yeah, thank you. All right, we need more, okay? We always need more. And folks have called us, I guess still call us the GitHub of machine learning. I think that's fine. I don't mind the GitHub is cool. So I don't mind the analogy, but you will see we're actually building more. And we're trying to be more than a nice collection of models and data sets. So we have all those nice companies as investors as of last summer. So that's good validation for us. We'll try to put that money to good use for the community. And I think more importantly, it's really good validation for open source AI generally, right? Because all those folks, almost all of them are also building closed models, right? And fine, it's never black or white. And if you came here to hear me talking shit about closed models, and yes, it's a meetup, so I'll go a little more French than I used to with customers. I'm not gonna do that. Okay, I think closed models have their own use cases, and I think open source AI is generally a better idea. But anyway, there's probably room for everyone here. So the mile-high view on Hugging Face, and again, if you looked at Hugging Face a year ago, or if you've been experimenting casually, that's probably what you're aware of. So models and data sets, right? Bottom right corner. An insane number, arguably. I checked this morning. I actually updated the slide this morning. So 680,000. It might be 690,000 by now, but who knows? And 150,000 data sets. Okay, and so all of these are open sourced, although they have different open source licenses. So please be mindful of that. Okay, not everything is fine for commercial usage, but if you pick stuff that has, let's say, an Apache 2 or an MIT license or a Llama license, you're good to go. But just be careful here. Okay. So models and data sets, we call them Hugging Face models, but it's really not Hugging Face models. It's community models, right? We're the stewards. We're the model herders. we welcome them, we try to take good care of them, but they come from the community, which means everyone from Google, Microsoft, Meta, to universities and startups and individuals too, right? So those data sets and models are the raw material for your AI project. The next logical step would be to work with those models and data sets through our open source libraries. So the most popular one is called Transformers. It's the one that made Hugging Face popular, but over time we added quite a few more. If you go to our repo on GitHub, you'll see many more. Diffusers, you may be familiar with, is the one for, let's say, stable diffusion models, text to image, text to video. Accelerate is distributed training made simple, and text generation inference, TGI, I'll come back to TGI later, is our own inference server. So it's the one you can use to deploy LLMs, and it's the one we use in our own services and in our cloud integrations. And there are way more libraries. You can read about them. Over the course of building Hugging Face, we've also implemented a couple of cloud services of our own. So Spaces is basically machine learning demos. I'm sure you've seen Spaces before, small web apps that you can write and host on our infrastructure, and to showcase models in a web app, not in a Jupyter notebook, but you'll get notebooks today. And inference endpoints, as the name implies, is a model deployment service. And you can one-click deploy 99.999% of our models, I guess, on any one of the three major clouds. Okay, and again, this is a fully managed service, so you deploy it, and we take care of everything else. So that's really I would say the core of the platform. I forgot to mention the Enterprise Hub, which is basically a layer of security, compliance features for enterprise users on top of the existing hub, right? SSO, auditing, all those good things. So that's probably what you know, but there's more. So we're not a model building company, but from time to time, there's an opportunity for Hugging Face to actually add new models to the open source collection, and we do that. Okay, so Bloom was in 2022 was the first open source LLM to compete with GPT-3.5, very large model. StarCoder, as the name implies, a code generation model. And Idifix is a visual large language model, so you can chat with images, etc. Pretty cool stuff. And there will probably be more at some point. Hugging Chat is our open source chatbot. So if you want a fully privacy preserving chatbot, this is it. It's based on a curated list of the best open source models, probably 6, 7 models. We upgrade them all the time. So you can actually select the model you want to chat with. And from UI to backend to models, everything is open source. So you could actually grab all the bits and pieces and redeploy them in your infrastructure if you want it. There's an iOS app also. So if you have an iPhone, you can chat with the best open source LLMs on your iPhone. We have cloud partners, and as you can imagine, with them, we try to integrate our open source ecosystem into cloud environments, mostly machine learning services. And we have hardware partners. And as you can imagine, we focus on accelerating training and inference across the board, right? And that work lives under the Optimum umbrella. Optimum is a collection of open source libraries, Optimum Intel, Optimum AMD, etc., where we provide, I would say, transformers-like API with built-in acceleration, right? So hiding all the hardware acceleration, all the SDK complexity, so that you just import whatever Optimum library matches your hardware, and automatically we accelerate and optimize training and inference, right? And last but not least, we have a consulting / professional services program, which we call expert support. And that's where we can engage directly with customers and help them build and help them bring their models to production quicker than they think, hopefully. Okay, so double clicking on LLMs a little bit. So all of you here at some point have tried at least ChatGPT, right? So maybe that's the only LLM experience you have, and that's fine. You know, we don't need more than that to understand here. So when you work with LLMs, first step is just use them as is, right? Ask a question and get some kind of answer. So that's fine. That's easy. That's what LLMs are for. But very quickly you realize maybe the answer is correct. Maybe the answer is what you wanted, but not in terms of tone of voice. Maybe it's too formal. Maybe it's not formal enough. Or maybe it's too long. Maybe you wanted a yes or no answer, or maybe you wanted 3 bullet points, you know, that kind of thing. So very quickly, you need to start providing instructions. And this is called prompting. And please do not call prompt engineering, okay? Any prompt engineer in the room? Just asking. How? Maybe on Zoom, okay, somebody's, okay, you can always log off and yell at me on LinkedIn or Twitter, okay? But, or you can hang on and take it. So prompt engineering is, there is no such thing. It's prompting is useful if you limit yourself to exactly what I said before, which is tone of voice, I would say safety guidelines, and output control, right? Brevity, formatting, etc. Okay, that works very well. When it breaks is when you try to teach the model new things through prompting, right? You think that showing 5 examples of whatever it is you're after is enough to teach the model how to generalize on every single case. The so-called many-shot prompting, okay? So that works for very, very basic things. It doesn't work for complex things, okay? And the analogy I take all the time is I never learned COBOL, okay? I learned a few programming languages, but not COBOL. And I know I don't intend to learn it at this point. So you could show me, let's say you wanted me to become really good at COBOL debugging. You could show me 20 examples of buggy COBOL snippets pointing bugs at me, right? And okay, I could read, and through analogy, because I learned all the other languages, I could say, oh, okay, so the variable here is misnamed, okay, all right. And here there's a missing comma or something. And there's an obvious typo, okay, all right. So by analogy, I could pick up a few things. Now, show me more complicated examples of, logic problems or, keywords that don't even exist in the language, etc. I wouldn't know. And if you could show me 100 examples, I would never really be good at this, okay? Because it's shallow knowledge. Few examples will never turn me into an expert, okay? And yet you try and, well, the community, try to turn vanilla LLMs into legal experts or engineering experts with 5 examples. And I'm sorry, but no, okay? If you need to do that, and a lot of you need to do that, bake new domain knowledge or deeper domain knowledge into LLMs, there's a procedure for this. It's called fine-tuning. Okay, so fine-tuning means training the model for a particular task. I want this particular LLM to be able to answer legal questions. Legal questions in the oil and gas domain, okay? Okay, it's a very narrow slice of knowledge. So what you need is probably an inch wide, but you want a mile deep. You will never ask for cooking recipes. You will never ask for poetry. You will never ask for astronomy questions, right? You don't care. Or answers, I guess. You will ask the questions. So fine-tuning lets you do that. Then the next level up is called continuous pre-training. So continuous pre-training is pretty much what the name says. So initial training or pre-training is training completely from scratch, okay? So you have 1 million pages of legal documents for the oil and gas industry, and you want to build the ultimate LLM for that. Okay, so fine, go and train your model from scratch on that million-page corpus, and it will be pretty good at this. Okay, that's a big effort. That's an expensive effort. Maybe you don't have 1,000,000 pages. Okay, maybe what you have is maybe you have 1,000 new pages every month. Okay, so you could say, well, can I take my vanilla LLM, train it on 1,000 pages? And then maybe next month or in 6 months, can I train it again on another 1,000 pages? Incrementally training until you get to something that's good enough. Yeah, or maybe saying, it's good at oil and gas legal, but now I need, nuclear energy legal. I would like to have the same model doing the two things, right? So this is called continuous pre-training, right? So all those techniques are useful. And in parallel of that, there's retrieval augmented generation, which has spread like wildfire, literally. And I will do a RAG demo, and you'll see the benefits of that, right? As you can guess, the higher we go, the better the domain adaptation, right? So the deeper you go into the answering precisely and with great detail, etc. But because nothing's free, the higher you go, the more complicated, expensive, time-consuming it gets. Okay, and I wanted to provide estimates, but I've seen a lot of variability. So yeah, it's difficult. Initial training for sure is going to be hundreds of thousands of dollars, if not millions, right? Fine-tuning could be very cheap, as we'll see. So, of course, we want to be reasonable. So start at the bottom, evaluate in terms of accuracy, etc., and only move up if needed, right? Please. Okay, yeah, let me repeat the question for the folks on the Zoom. So the question is, for fine-tuning and continuous pre-training, do I expect companies to build one model per use case per domain, or will we see industry domains? I'm rephrasing a bit, but that's what you meant, right? Will we see industry models coming from large players? It's a good question. I think so far the attempts at industry models haven't been super successful. Some companies have tried that, the healthcare domain, the healthcare LLM, maybe the legal LLM. I think these are interesting as a foundation for your own fine-tuning efforts, right? Because after all, if somebody goes through the pain of, oh, I've got 1,000,000 pages of legal corpus, and I clean them and prepare them and train them, that's great, right? But if you work at Amazon, okay, and you want to build Amazon.com, and you want a legal LLM for the retail domain at Amazon, and even that is probably even too general purpose, right? Because maybe you're dealing with vendors, or maybe you're dealing with supply chain partners, right? And there's a different take on all of that stuff. So it's difficult to see an external vendor, training a model that is so good, so relevant on all your awkward domain knowledge and specific vocabulary and product names and policies. It would be so great that you would use it out of the box. So healthcare might be different because, again, there's a lot of public knowledge. There's a lot of public reports, research reports. But imagine you're working for, Pfizer, or there's still a lot of built-in confidential knowledge that you need. And how do you inject that into that model remains to be seen. So sorry for the long answer, but so I would say my dream scenario would be we see open source LLMs for particular industries, particular businesses, right? Trained on as much public data as is available out there. And then companies take that and fine-tune on their data. But again, it's never black or white. So I'm sure some industries would work with an industry model because 99% of the knowledge is out there, right? Research activities, and God knows what, right? Please.
Yeah, for the folks in the Zoom, the slide is cutting off on the right side of the right side of the slide is cut off. Not
Oh,
sure if it's just me or everybody.
wait. Let me. No, no. Actually, I don't know. Is that the Zoom? Is that the real Zoom thing? No, they say the rights.
Yeah,
Well,
there's
just now you showed the whole slide when you had that little one that it did show the right-hand side without being cut off. So whatever you did,
Oh, okay. So you work now? Okay, okay, all right. I don't know. Well, okay.
show the ML arrow on the side. Okay, it's cut off again. When
Yeah,
you
it's
made
cut off
it
again.
small, it showed the whole thing, but not now.
Okay, I can.
Yeah, now we can see it. Yeah,
Okay, all right. Okay, well, I can stick to this
yeah.
if okay. Um, yeah, is that yeah, okay, I can see. Okay. All right, well, yeah, we'll stick to this view if that's okay with you, right? Um, all right, yeah, we can do it like that, sure. Oh, yeah, you had a question over there.
like incremental data.
It could be, yeah, it could be incremental on the same domain, or it could be trying to add a few different domains. You know, it could work. It could work. I would see mostly improving the same domain, right? Not having to refine tune from scratch, which is always boring. Generally, it's let's do a first round, evaluate. It's working, but not for these questions. So how do we fix those? Right? Those don't really work. Okay, let's add some more examples. Let's train a little more. Okay, the old ones still work. The new ones work a little better. And then until you get to, good enough, right? Of course, you could refine completely from scratch. But if you have something that you kind of like already, you don't want to tear it down and remix the data sets, and maybe the result is widely different. So yeah, there are different techniques there.
Julian, you know, I've already been hearing about, small language models,
Yep.
it's not complex enough with large language models. And so are we to understand that small language models are more for like embedded devices or something like that? Or
No,
is that,
no, it's
yeah,
it's man, we don't need more buzzwords.
all right.
So yeah, we call them large language models, and now should we call them small large language models, or
Yeah.
whoever invented that, deserves it.
Okay. Well, I
There's
was just curious because I,
citation in hell. So and they're all large, by the way. I mean, if you compare that to XGBoost models, I mean, they're humongous language models, right? So I think small language models. Now, if I don't know if there's any consensus, but I think large language models would be almost synonymous with closed models, like Gemini, OpenAI, Claude would be LLMs. And anything smaller than, let's say, 70 billion parameters is going to be small language model. So, but honestly, it is a bullshit definition. So I prefer to talk about open source versus closed. I think that split I can understand. And where's the limit for small, right? Is 70 billion a small model, or is it 13, or is it 7? I don't know.
all right. Thank you.
I agree with you. It's weird. I agree with you. But if we agree that GPT-4 is a trillion parameters, then okay, 70 billion is small, right? I think that's kind of the story there. All right. Okay, so yeah, so you're probably there, right? You're probably in that orange box. Well, that's where most of the customers are anyway. So starting with prompting, adding RAG, we'll see why in a minute, and eventually, I guess, doing some fine tuning for further adaptation. That's the majority of customers right now. So let's double click on RAG and do maybe the first demo here. Yeah. So that's the high level architecture for RAG. Okay. Is anybody seeing this for the first time in their lives, which is completely fine? Yes, fine, no problem. We're here. So what RAG is basically adding external data to the mix for generation. Okay, so instead of relying on what the LLM knows, what the LLM has been trained on, which is generally too old, right? You know, what's the weather? I mean, do I need a raincoat in Austin tonight? Sorry, my cutoff date is September 2021. So, well, okay, yeah, no, you know what I mean, right? There's no freshness here. So the only way you can get freshness and the only way you can add confidential data from your company that obviously was never found and should never been found in LLM training sets is by having this external source of truth, right? So you take, and that's the ingestion process, okay? So you take that data, you run it through an embedding model, we'll see what that is. You turn that data into high dimension vectors, okay? So it's text, let's say, text paragraphs to high dimension vectors, and you store those vectors in some kind of backend, okay? And then when a user asks a question, the first thing you do is convert the question into a high dimension vector, run similarity search between the query, the vector query, and your embeddings, okay? And retrieve, let's say, the top 5 or top 10 vectors that closely match the query, okay? And these will match to the documents that hopefully have the information that store the answer, okay? And so you pull those documents back, and the prompt, and you will see it in a demo in a minute, the prompts look something like, as a friendly AI assistant, please answer the following question, blah, 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 using context found in the following documents, okay? And this is how you can inject information that happened 5 minutes ago and information that is very private and very confidential to your org, okay? So this looks like a really complicated slide, right? And so I'm going to show you how to do this in a single notebook. Yes.
In your previous pyramid diagram, you put RAG across the big slice of it. Here, this is saying that RAG is actually not.
No. You could, these are different things. RAG brings freshness of data plus access to company data, okay? And it's a good first thing to try. And then you could say, if I want to make this better, maybe I can fine tune the LLM for tone of voice, right? I want the LLM to tell me stories in a particular tone of voice. If you build, let's say, an oncology chatbot, and your LLM sounds like an excited teenager, that's not flying, right? Oh, yeah, absolutely. I'm delighted to tell you about Mr. Jones's cancer. What? No. Okay. And prompting can help with that, but maybe at some point you still want to bake that behavior into the model. And you could also fine tune the embedding model, the one you use for vectorization, to specialize it for a particular domain. So yeah, it's generally you will try RAG first because you need fresh company data. And for further accuracy, let's say, you will do fine tuning. You need all of them. These are all the knobs you can turn, right? In the end, you need prompting, you need RAG, you probably need fine tuning, But more than anything, you need to know what happens when you turn prompting to 11 or, you know, fine-tuning to 0. Because if you have no sense of this is the effect that thing has, then yeah, you can keep twisting that thing and, you know, you're going to break things more likely, right? Okay, let's look at, and I don't know why my screen is turning dark now. It's kind of crazy. Give me a second. Yeah, okay. I don't know. Where is my notebook? Okay, so yes. Can you read or yeah? Is it large enough? Yeah, okay. Yeah, you're saying no. You have glasses like me, right? Okay, let's try it a little more. So, so what I'm going to do here is exactly what you saw on that slide. Okay, let me come back to this for a second. So I need 2 models. Okay, so I need an LLM. So I'll deploy an LLM on SageMaker, Amazon SageMaker, and I need an embedding model, which I will run inline. Okay, my ingestion process will be 3 PDF files. Okay, we'll see that. And I will use, I won't use a proper database. I will use an in-memory library. I'm going to use Face from Facebook. But you could use, I have another demo where I use OpenSearch, etc. And I'm using LangChain to run everything, hopefully. Okay, so let's take it step by step. So first I need to deploy my LLM. Okay, so that's what I'm doing here. So I'm deploying the latest version of Mistral 7B. All right, and that's the full code. There's nothing else. So this also shows you the SageMaker integration for Hugging Face, right? And you can do this for the huge majority of models on Hugging Face. So just define what model you want, okay? Create a Hugging Face model object in the SageMaker SDK, call deploy. Here I'm deploying on a small GPU instance, okay? So when people tell me, oh, deploying LLMs is a project, what do you mean it's a project? It is not. And you know what? It's even better because if we look at this model on the hub, we click on deploy, SageMaker, this is the code. We actually generate the code for you. So all you have to do is copy and paste. Okay, and that's the GPU code. And if you want to deploy on the AWS Inferentia 2 chip, you have the code too. Okay, so don't tell me it's complicated to deploy LLMs on AWS. It is as simple as that. Okay, oh, no, that's not the right one. No, still not the right one. I've got the wrong window. Yeah, here, okay. So we wait for a few minutes and we have Mistral 7B deployed. Yes. Are you going to say EC2? No. The door's here. No. No, seriously, no.
But would it be possible for you to
Of
repeat
course.
the
Oh, yeah.
questions?
But don't count on me for that. You know, it's like in 2024, if you are telling me you will be great at building an inference container or whatever, and you're gonna do it yourself on EC2 or EKS, you know, I wanna cry. You know, there's zero reason to do that. Okay. If you want to grab the model on Hugging Face, reinvent the wheel in terms of compute environment on EC2, EKS, ECS, on-prem, whatever, be my guest. Okay? And that's my diplomatic way of saying it. And don't push me because I'm going to be too French for you. Okay? Yeah. No, seriously. I'm super happy with copy paste. Wait for 7 minutes and have a scalable production grade LLM in the cloud. right? And that's what we've been building with AWS for 3 years. So I'm not telling you this because we fell in love with it, you know. It's just that, you know, come on. It's like 5 years, 6 years ago, people telling me, oh, I can't really use DynamoDB, you know, because it's different. And in fact, we have our own in-house NoSQL database online. Yeah, that sounds awesome. You know, like the rest of us, we're very happy with cloud services. Okay.
Hey, Julian, a couple of requests coming in from our online friends.
Please.
If it's possible to share the link for
Yeah,
this.
absolutely.
Yeah. And the other one is that if you can repeat the questions coming from the room.
Oh, yeah, sure. The question is, I don't want to do SageMaker because I love to reinvent the wheel on EC2. How do I do it? Right? So the answer is go do it. You know, you don't need me. I'll copy the, yeah, give me a sec. This is it. I'll put it, where is the chat box for this thing? No.
If you go to, where is your Zoom interface? If you click on, yeah. You know, Zoom keeps on changing their thing.
This one, I guess. Yeah. No.
Let's see. No. Do you see any?
I'll send all the links to.
No worries.
Okay.
Yeah,
Okay. Sorry.
No problem.
Oh, here it is. No, it was hidden. Okay, it's here. Okay. Here it is. Yeah, here it is.
Perfect. Thank you.
Yeah, you're welcome. Okay, so we have the LLM. Okay. So now it's a SageMaker endpoint. So we need to plug this thing into LangChain. Okay, so it's not too difficult. What this really does is LangChain needs to know how to serialize and deserialize information coming from the endpoint. Okay, because every endpoint is a little bit different. So this is what it looks like. You need a content handler. Turn the input to JSON, transform the output from JSON, and take into account the prompting format for Mistral, which requires those inst/inst tags. Okay. Honestly, that's a detail. Don't worry about it. Okay. So now LangChain knows, right? Through this, LangChain knows, oh, okay, that's a SageMaker endpoint. I know how to send it data. I know how to retrieve data. Okay. It's really plumbing. So we could try asking a question, right? Directly. So here, let's say, as a helpful energy specialist, please answer the question, focusing on numerical data. Don't invent facts. If you can't provide a factual answer, say you don't know what the answer is. In other words, don't invent silly shit, okay? And create a template, create a chain, and then ask a question. What is the trend for solar investments in China in 2023 and beyond? Okay? And here's, so run the chain, which sends the query to the model, and just print. If I print everything, it prints the prompts and all kinds of silly things I don't need. So I just want the answer. It's actually not such a bad answer. It says, I don't have real-time data or the ability to predict future events. So much for AI. Yeah? However, according to the International Energy Agency, blah, 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 blah. Okay. So this is actually this is the best case scenario. The model doesn't know, it's telling you it doesn't know, it's trying to do its best based on what it's been trained on, but it's not hallucinating, it's not, which is why Mistral is a good model, you know, it's not pretending to, but still, it's not a great answer, okay? So let's add RAG, okay? So, because now we just ask the model. So I'm just grabbing 3 PDF files from the International Energy Agency. Okay. Copying them to S3, right? We see them here. And then I need to extract the text from those PDF files. So, and I'm very lazy about this. And as it happens, there is an AWS service to do this, which is called Textract. So that's what I'm doing here. So asking Textract, hey, extract all the text from those 3 PDFs, okay? And chunk them, so split them in 256 byte chunks, okay? So we see we ingest all 600 pages or something, right? So it's a good amount. Took a few minutes. So now I have thousands of chunks, text chunks coming from those docs, okay? So I have this chunked. Now I need to run it through the embedding model to turn that stuff into vectors, okay? So I need an embedding model, and I'm going to grab a small embedding model on the Hugging Face, right? So it will take the text and output a high dimension vector, right? So download this, again, LangChain as an object for that. Very simple. And now embed all those chunks, right? So run every single chunk through the embedding model, generate that high dimension vector, and store it into my face in-memory database, okay? And I can save it because I don't want to do that again and again. So once I've done that, and you see it's very fast, right? 2 seconds. Now I've built this, okay? So all my chunks have become vectors, and I can now hopefully retrieve them. Okay, so let's go away. Okay, so now let's configure, let's put all those things together, right? So I'm going to use my collection of vectors as my source of truth. Okay, I'm going to retrieve 10 chunks every time I query. My template looks something like this. Okay, so same prompt as before with the user question and the context. And the context will be the 10 chunks I retrieved from the backend, from the face collection. Okay, put all those bits together with another chain. And now I can ask the question again, okay? What is the trend for solar investment in China in 2023 and beyond? Okay, so exact same question, except this time, we're going to embed the question, use that embedded query to find the top 10 documents that closely match this, retrieve them, and inject them into the prompt, just like we saw here, the context. Okay, and here's the answer. Based on the provided context, it is expected that solar investments in China will continue to be significant in 2023 and beyond. In 2023, approximately 380 billion is expected to be invested in solar globally, blah, 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 and I see more numbers. Okay, much better answer, right? Okay, and the model is actually telling me based on the provided context. So it says, well, whatever I'm telling you after this is actually based on what I retrieved. So if my retrieval model did a good job, bam, I hit the jackpot here. Okay. And I could ask the model, hey, quote the exact, quote the page you found this information in. And I mean, this is just a very simple demo here. Okay. So this is RAG in action, right? So like I said, RAG in a notebook, right? Very simple, not crazy scalable, but good enough to get started, right? Good enough to get started for sure. And exactly what we see. Okay. So LLMs from the trenches. So in the last 8-9 months, I have met something like 250 customers, I would say. Okay. 200, 250. And this is a bit of a summary of that. So retrieval augmented generation, which we just saw. So it's everywhere. Okay. So like I said, if it's the first time you hear about it tonight, well, you can go home happy because you learned something super useful, right? If it is really the first time, then keep learning about RAG. It is everywhere. It's a super popular technique. It works. You can see it for yourself. Even my stupid notebook demo already shows RAG works on just a few hundred pages. Yes. RAG doesn't change the model. There is no training involved, right? The models I deployed in the previous notebook are just vanilla models, no further training. Okay, so means cheap, simple, right? So the thing is, a lot of people do RAG, but I don't think they fully come to the right conclusions. So as we saw, the knowledge, the fresh knowledge comes from the external source of truth, right? Not from the model. We saw that very clearly. The model doesn't know anything about coal in China in 2023. You can't blame it, and this is 2023. If you ask about 2024, you can't expect the model to know all the new stuff. Fine. What this really means is the model is just a writing assistant, right? Here's my question. Here's the context. Write me a good story, right? Use that knowledge to write a story based on my guidelines. Which means if you're not using the built-in knowledge of the model, why would you want to work with a very large model? Because a very large model is large because it has more parameters. Why does it have more parameters? Because it stores more knowledge. Okay, so when I see folks doing RAG with 70 billion models, I'm a little skeptical, right? And then the first question I ask is, have you tried smaller models? Because you are probably overspending to run inference on a model that you don't fully use in terms of built-in knowledge. So Mistral is 7 billion, but you could probably go lower than that. Particularly, Microsoft has released a family of models called Phi, PHI, Phi 3, actually, the latest ones, which are, there are different sizes. I think the small one is 3.8 billion, 3.4, 3.8. And it's a very good candidate for that. Because you don't need a ton of built-in knowledge, right? The model will never know what you want it to know. So let's just go and use smaller models and save. The next thing I want to touch on is context size. Okay, so AI marketing in action. Big numbers. Mistral here is, and the others typically have, let's say, 8K context, which means you can pass 8,000 tokens, right? Roughly, let's say 7,000 words, right? Some people want you to believe that you need way more than that. You need 100K context. You need 1 million context, 10 million, right? Somebody will say 100 million before I'm home. So this is complete bullshit. I think people don't understand what 100,000 tokens mean. So the typical novel, okay, is 100,000 words. So that would be, let's say, 130,000 tokens for English. So if you're passing 100,000 tokens, we're talking a full novel, okay? So 200, 250 pages. And then you're asking a question. So my question to you is, what is the use case for this? Okay, I keep asking everybody. Okay, no one comes up with a reasonable answer. Some VP the other day told me, oh yeah, but for code reviews, we can pass 100 pages of code. And I'm like, is this how you run code reviews? I mean, I've done a lot of code reviews in my life. I don't think we've looked at more than 10 pages, right? Oh yeah, but if, and I'm like, okay, if. So if you need that, then go and use the crazy large context size, which is of course crazy expensive and crazy slow, but no one ever tells you that. In the meantime, for the other 99.99% of usage, can you please use 8K or 16K context and save a ton of money and latency? So please don't fall for that, okay? Please don't fall for that. Okay, next item, model customization. So if we had met, let's say a year ago, and you had told me fine tuning, right? I want to fine tune a 7B model. I would have told you, yeah, you can do that. And it's going to cost you maybe $10,000 to $20,000. Not for everybody, right? Now I would tell you with a straight face, you can do it for $10 to $20. Okay, and it's a fact. Yes, I said 10 to 20. I see you're going, what? Yes, fine-tuning, not, yeah, the real thing, fine-tuning. And the reason for this is because of a class of techniques called parameter efficient fine-tuning, or PEFT. Okay, another acronym if you want to sound smart. Now you know RAG, and now you can say PEFT, right? And you can put AI in your job title, and you know more than 90% of people. And those techniques are called LoRa and QLoRa, and I'm not going to go too deep into that. But what they do is, instead of fine-tuning 100% of the model, so all the model weights, which will take time, right? You fine-tune, let's say, 0.1 or up to maybe 1% of the model, right? And you literally just tweak 0.1% of the model, and you get very close to the results that you would have gotten with full-on fine-tuning. Okay? Yes, it sounds like magic, and it is. It's math, actually, so it is magic. Okay, so that's why I'm saying it dropped 1000x, because if you're only fine-tuning 0.1%, it's 1000x fewer parameters. So about the same factor for cost. So yeah, I've got demos. You can find them on my YouTube channel. Fine-tuning Llama 2 for $5, and it's pretty cool. Another problem to solve on fine-tuning was so everybody has learned about reinforcement learning with human feedback, RLHF. It's amazing. It's what made ChatGPT amazingly good. But HF is difficult. Human feedback means you need humans. So you need a task force to look at what the model generates and fix it. Okay. No, yeah, that's kind of an okay answer, but this is actually a better one. So next time you train, keep in mind this is the better answer, right? So you need folks to do that. And even if you have folks to do that, sometimes things go wrong, right? Remember the Google model from a few weeks ago? I'm from Europe, right? So I can be sarcastic about this, but we had Nazis in Europe a few years ago. We still remember what they looked like, and they didn't quite look like what Gemini was generating. I'm sorry, but right? Sorry. I think we would remember, right? I think we would remember if they looked like that. But anyway. So that's not AI failure, that's human failure. It's alignment gone wrong, probably with good intentions, but the road to hell is paved with good intentions, as we say. So alignment is a problem. So if we could get rid of human feedback, not only would we make it simpler and faster to give models feedback, and we hopefully would eliminate misalignment. So there are lots of good techniques. They have crazy names: DPO, PPO, ORPO. They all end with O because it's optimization. This would be another 4-hour talk. If you're curious, you can go and read those blog posts by Argila. They tell you everything you need to know. And last thing I want to mention is this thing called model merging. Who has heard of model merging? Yeah, it's still quite new. So it's exactly what the name says. So you're not training anything. You're taking models and you're running averaging on them. Model A, 20% of model A plus 80% of model B, literally averaging weights, and bam. So yeah, I've got the math model, and I've got the code model, and I've got the legal model, and I average all of them to have a model that can do math, code, and legal. Yes, it sounds crazy. I'm sorry? Oh, they're very impressive. The results are very impressive. Yes. The library to do this is called MergeKit. Go check it out. I actually did also a video on the different merging techniques with some intuition on how they work. And I have links to the papers, and the papers I've benchmarked where they literally do that. Seconds on your laptop, because it's literally averaging weights. So there is no training whatsoever. You don't need GPUs. So that's the appeal. Because you can start from hundreds of thousands of models on Hugging Face and cherry pick the ones that have the knowledge that you like and build a model that has all of them. Now it could be 70B, it could be. It's just a simple algo, honestly. There is no training involved. You don't need GPs. It's literally loading model weights and averaging them out. Okay. So mixture of experts. So the question is how is this different from mixture of experts? Mixture of experts is you train different copies of the same model, okay, in parallels, hoping that they learn different things. Yes, and some, yeah, it's at training time. So you have 16 copies of the same architecture trained in parallel, slightly different ways so that they pick up different things. And then at inference time, you pick a subset. So you predict with only 2 of the experts or only 4 of the experts, which saves on latency. But you still need to load everything, and you still need it to train everything. So still very intensive. Merging is just model A, model B, model C, different weights on those models, build me a single model in the end, right? It is crazy. You have to, I never fully trusted it. And I don't know if I fully trust it, but if I trust the papers, the results are pretty impressive. And the compute is seconds. I'm sorry? Question is, how do you control for hallucinations? I don't think it's really different. You would still need to run evaluation. You would still need to run the same QA on your model. I think the appeal of merging is, I have lots, again, there are tons of models out there. So I have probably enough knowledge out there, but it's in different models, right? So I'm going to cherry pick stuff that makes sense for my use case, and build a model that has those capabilities. But of course, you still need to test it, right? We'll get to that. Okay, we'll get to that. Okay, so real quickly, the rest is more, I would say, is important, but it's a little more straightforward. So this year is about moving stuff to production, right? We still experiment, but people want results. They want to see AI in action and not just AI POCs, okay? So that means cost performance is everything. So if you're not evaluating, if you're not thinking about, your latency budget, your throughput expectations, if you're not thinking about the expected ROI target for this project, you will be disappointed, That stuff doesn't fix itself. You need to work at it, okay? If you don't think about that, then you will have a very nice POC, but that can't scale, or is too slow, or is way too expensive, okay? And keep in mind, inference is the huge cost here, not training, okay? Fine-tuning is very cheap now. Model merging, if that becomes successful, will eliminate training cost. So in the end, what's left is inference, right? And that's, I keep saying inference is forever. The model is deployed, it stays there until, till the project dies, but that could be years away. And it needs to scale according to traffic. So if you are not thinking about optimizing your inference cost, you're not thinking about cost performance, okay? And in terms of hardware, yes.
So you can actually take advantage of that inference time. What you can do is you can deploy the base model once, and you can deploy multiple versions of the model. Then you can stop that.
Yeah, you can have adapters. Yeah, sure. Yeah, I won't get there. Yeah, but sure. There's a lot of work you can do on inference optimization. So if you're not considering it, you are missing out. Okay. So I mean, don't lose any sleep, on the first week of the project, but it needs to be on your map at some point. Yeah, not just NVIDIA GPUs. I mean, they're rich enough. That's okay. There's not enough of those. They're crazy expensive, and there are alternatives now. So there's this company called AMD, right? You know about them, okay? They have a really good GPU, which is the MI300, which is hitting the clouds at the moment. So go and check that out when you can. We like it a lot, and we see better cost performance there. The AI accelerators from AWS and the other clouds are equally interesting. Okay, so go and check that out. If you listen to me and try to use small models, then you should be able to use mid-range GPUs, which are plentiful. For example, G5 instances on AWS, about $1 an hour, perfect for 7-8 billion parameter models, which are really the sweet spot right now. No need to go any bigger than that. You can find, as many as you want. You can scale out. This is the best option, I think. And of course, local CPU inference is quickly becoming a thing. And we work with Intel and AMD, and we see a lot of work being done there on CPU inference and the model optimization for local inference. The major blocker here is the companies who build models need to find a way to charge you for local inference, right? Why isn't GitHub Copilot a local thing? There's no reason for that, right? It could be local, but they need to be able to charge you for that. Once they figure out how to get your $20 a month on your laptop, you'll have a local copy, right? Trust me. All right. Yeah, we'll don't need to cover that. So how do we know which models are the good ones? So we have this thing called the leaderboard, the LLM leaderboard, which everybody is trying to game, and because apparently getting to the top of that leaderboard is a thing. Competition, right? So let me go full screen. I hope, yeah, because there's nothing on the right. Okay, yeah, because it's too small otherwise. So this is the version from March 20th, as you can see, okay? So I know it's busy, but what you see here is models, pre-trained models, 7 billion parameter and slower. Smaller, not slower. They would be faster. Okay, 7 billion, it's jet lag hitting my brain. 7 billion and smaller, okay? So Google Gemma 7B, Qwen 7B, Microsoft Phi 2, blah, blah, blah. And the best one is 6375. I actually updated this slide this morning, especially for you, because I thought, man, this is way, way too old now. Okay. So this is this morning. Okay. Same screen, 7 billion and smaller pre-trained models. So Phi 3, Microsoft is at the top, 6986 average. Okay. Higher is better. We don't care what those models are. what those numbers are. Google Gemma is still doing well. Llama 3 popped up, okay, came out mid-April. Qwen is still here. Mistral is lower down the list, okay? So that's, okay, that's 2 months, okay? Arguably, May was busy, okay? I'll give you that. April, May was a busy time for new models, but that's the pace of innovation there, okay? So you can't sit for 12 months and hope that whatever you have in production today, it'll still great in 12 months, right? It will still do the job, but chances are there's a much better model that has already come out. I'm not saying you should upgrade every week or even every month. What I'm saying is you should definitely keep an eye on the new models and measure how far ahead is this new thing on our data, not on the benchmarks. Run evaluation on your data. And there comes a time where the gap is large enough that you will want to switch, okay? But coming back to my original obsession on prompting, if you wrote those very elaborate prompts, right? Do you think they will still work the same? Right? If you were on, let's say, Gemma 7B, and you now switch to 5.3 mini 4K instruct, whatever the name is, do you think the prompts work the same? Maybe, maybe not. I can tell you the longer they are, the more domain specific they are, you know, the more dangerous they are. So you will rewrite that stuff. So prompts are technical debt. You need to know that, okay? They are technical debt. It's a shame that you have to rewrite all those things again and again. So if you keep the prompts generic, you'll be in a better place. I would actually recommend that even if you picked, let's say, Gemma 7B, right? Let you try your prompts on Mistral and 5.3 and 2-3 different models, like regression testing, right? And check the different answers automatically. Compare the answers automatically. If you see very, very different answers, something might be off. Maybe you went too far into prompting. If you see reasonably similar answers, okay, right? So quickly, for performance, tokens per second, memory usage, etc., we have the performance leaderboard, right? Which helps you find the right model size and for your infrastructure, your latency, etc. We have an embedding leaderboard. We saw how embeddings were, how important they were for RAG, right? Embeddings are really cool again. Lots of new models coming out, and we have a leaderboard specifically for that as well, okay? Specifically for embeddings fans, this came out a couple of days ago. So sentence transformers, version 3.0 major release. So sentence transformers are another library that we steward specifically for embedding models. Okay, so if you are if you are deep into embeddings, you want to read about this new release. Okay, so last thing I want to say, and then we'll call it a night, is this. Okay, so there's a lot of obsession about models. Okay, I'm actually not super interested in models myself. I think what you use today is not what you will use 6 months from now. And if I look at the models from 6 months ago, like Llama 2, right? Which was amazing. Amazing. It was a breakthrough. Llama 2 came out in July 23. Okay. If you are using Llama 2 in production today, people would throw rocks at you. Right? And that's July. Okay. So it's not even a year ago. Okay. Mistral was even better in September. You would probably not use Mistral in production today. Or if you were, you would certainly look at migrating to maybe Llama 3 or something else. right? And 6 months from now, probably you won't be using Llama 3. Okay, so look at the leaderboard, evaluate the 3, 5 LLMs at the top, right? Get value out of them, but don't fall in love. You will throw them away. The secret sauce is the data, okay? The data, especially if you do RAG and if you do fine-tune, okay? The one thing people don't talk about enough is machine learning engineering, okay? That's another 9 hours of discussion right there. What I mean by ML engineering is all the under the hood techniques to give you the best cost performance. And so once you have a model that you like, okay, maybe off the shelf, maybe fine-tune, how do you squeeze every bit of cost performance out of it, okay? So faster attention layers, right? Model compilation, model quantization, model merging, and of course, hardware acceleration, all those things need to be looked at some point, okay? Not on the first week of the project, but again, if you are not factoring in those techniques, saying, okay, this is a model I like, I have the business accuracy, and I think I can get ROI from this. Now, how do I squeeze this thing to make it 2x, 4x smaller, 4x faster, blah, blah, blah? You are missing out, right? Who wants to pass on 2x ROI improvement? Come on. No one, okay? So I've got lots of deep dives, again, on YouTube. Feel free to go check that out. And this is a really great place. I mean, if you love tinkering, if you're tired of DevOps or something, this is a great place to be, right? I'm more excited about this than anything else at the moment, I have to say. Yes. So the question is closed source versus open source. So we were having this discussion. So I think the two things to consider are how much domain adaptation do you need, and how much scale will you have? Okay, so you have this quadrant. So low scale, low domain adaptation. I need an AI tool for my marketing department to make their whatever they do, product pages, better, blah, blah, blah. Or my HR team wants to summarize resumes, blah, blah, blah. And they're not going to do that 50,000 times a day. And it's not very domain specific at all. Great. Honestly, it's a bit of a boring project too. So get it out the door with a model API. Go use, Amazon Bedrock, whatever model works for you there. Fine. Get it out the door in a few days. Move on to smarter things. Okay. And low scale means that cost isn't really a problem anyway. Paper token is overpriced. Okay. But I tell you all the time, if this thing costs $500 a month, there is no incentive to make it 50, right? Engineering time is precious. So let them spend 500 and move on, okay? So that's low scale, low domain adaptation. Then you have high scale, low domain adaptation, okay? You need to translate 10,000 pages of text every day, right? And it's not super domain specific. So what do you do then? Well, if you want ROI from this thing, you need the smallest possible model, right? So sure, you can translate with GPT-4 or Claude, etc. But then, if that thing costs you 10,000 a month, there might be an incentive to make it, 1,000. Okay, so as soon as you have scale, you need to consider the benefits of a much smaller. and much less infrastructure to support it. Okay. Then you have high scale, high domain adaptation, which is a no-brainer. Okay. Again, high scale means the smallest model possible, and high domain adaptation means you need to, at the minimum, to have RAG, and probably you need to do fine-tuning. Again, you need to finally control what's going on there, which you cannot with those model APIs, even those who offer you fine-tuning. Okay. And then you have the weirdo, which is high domain adaptation, low scale, where I would think humans can do it. You know, that's probably our, you know, that's probably where we can still exist. Because if it's low scale and high domain adaptation, it means you will probably spend quite a fair amount of time building a good model to solve those hard questions, but it's only going to be used 10 times a day. So it's like automation, you know, it's honestly, it is like automation. Would you automate a workflow? Would you do CloudFormation or Terraform for something you do, you know, from time to time? Is it worth it? Right? I don't know. Probably not. Probably not. Yep.
Let's wrap it up with here.
Yep.
And thank you for everybody for joining, and
Thank you. So I'll send you the slides.
Yes.
I'll send you the slides. I'll send you the links to the notebooks.
Yes.
And yeah, you can play with this stuff, right?
Great.
All right. Thanks, everybody.
you.
Thank you, everybody on Zoom.